All right, today we're going to be talking about rhombuses, rectangles, and squares. Our objective is that we will be able to verify characteristics of quadrilaterals and use properties of quadrilaterals to solve real-world problems. All right, first, recall that a quadrilateral is a four-sided polygon. And last class, we talked about parallelograms, which had the following properties. Both opposite side pairs are parallel. Hence why it's called a parallelogram. So this side is parallel to this side, and this side is parallel to this side. We also know that both pairs of opposite sides are congruent, meaning this side length is the same as this side length, and this side length is the same as this side length. We could also prove something's a parallelogram if one pair of opposite sides is both congruent and parallel. So if we know these pairs of sides are parallel and we know those sides are congruent. We know that both pairs of opposite angles are congruent. So this angle with this angle, this angle with this angle. Another rule about the angles is that consecutive angles are supplementary, meaning they add up to 180 degrees. So if this one's 80 degrees, this one's 100, which would make this one also 80, so that those are consecutive, they add up to 180, those are consecutive, those add up to 180. And then finally we have a rule about the diagonals. That diagonal, that diagonal. They cut each other in half, so this piece would be the same as this piece, and this piece would have to be the same as this piece. So diagonals bisect each other. Now, some more specific types of parallelograms are the rhombus, the rectangle, and the square. So a rhombus has all the properties that we just listed, and we also know that all of the sides in a rhombus are congruent. So this side, and this side, and this side, and this side, all equal. The diagonals this way. if you notice how they intersect, it forms a 90-degree angle. The diagonals are perpendicular. And then we also know that the diagonals cut the angles in half. So if this whole big angle here is 80 degrees, then we know each little piece would be 40 degrees. And we can do that because the opposite angles are still congruent from the parallelogram rules. So the diagonals bisect the angles. So those are the special rules for a rhombus. Special rules for the rectangles, and the first one I think you guys all know already. All the angles are 90 degrees in a rectangle. So right angle, right angle, right angle, right angle. And then our special rule for the diagonals of a rectangle is that they are congruent. So this piece is equal to this piece, which is also equal to this piece and this piece. And as for a square follows every rule that we've written on this paper. It's got all the sides congruent. It's got diagonals that I'm not drawing very well that meet at 90-degree angles. It's got its angles in each corner as 90 degrees. And the diagonals are going to bisect that, so this little piece over here would only be 45 degrees. And the diagonals are congruent. So this equals this equals this equals this, and everything we wrote on the top for the parallelograms. Squares just got a lot of rules going on. All right, so let's identify which type of parallelogram each of these are. Now it tells us already that each figure is a parallelogram, so we know the parallelogram rules are going to apply. Then we're going to identify whether it's a rectangle, a rhombus, or a square. So this first one, the special thing here is that the diagonals meet at a right angle. Well, which quality was that? That's for a rhombus. So we know that this is a rhombus because the diagonals are perpendicular. Now this next one doesn't give us a lot of information except for the fact that we know it's a parallelogram. In a parallelogram, we know that opposite sides are congruent. So this has to be congruent to this, and this has to be congruent to this. We also know that opposite angles are congruent. So if that's a right angle, this is a right angle. We also know that consecutive angles have to add up to 180. So if this one's 90, this one also has to be a 90, and its opposite angle has to be congruent. Well, which shape has 4 right angles and 4 congruent sides? That's the square. All angles and sides are congruent. And in number 3, again, opposite angles have to be congruent. Consecutive angles have to add up to 180. So if that's 90, that's 90. This is 90 and this is 90. We don't know about the sides, so we know it's a rectangle because we have 4 90-degree angles. All right, the diagonals of a rhombus WXYZ intersect at point V. Given that XZY, so X to Z to Y, this one right here is labeled for us as 34 degrees, and W to V is 7. Find the indicated measure. Well, we knew from our rules from a rhombus that the diagonals bisect the angles. So if this part's 34, this part is also 34. And we knew from our parallelogram notes that alternate interior angles are also congruent from our parallel lines by a transversal notes. So those are both also 34. So have we found WZV? That's that one right there. That one's 34 degrees. Now what about ZY? This one over here. I'm going to label it side A. We know that the diagonals of a rhombus meet at a right angle. And we know an angle. We know that if this half of the diagonal is 7, this half of the diagonal is 7. Well, we have a right triangle. We got a side and an angle, and we're trying to find an other side. That sounds like a job for SOHCAHTOA. So I'm going to take this out so you guys can see the right triangle that we're dealing with. So we know that this side's 7, and we're trying to find this side. So in SOHCAHTOA, across this, that would be our opposite side. This will be our hypotenuse, so I'm going to get rid of this. Let's make that an H for hypotenuse. And that's our adjacent, but that's not a big deal. If we know our opposite and we're looking for hypotenuse, O and H, that's sine. So sine 34 would equal 7 over the hypotenuse. So the hypotenuse would equal 7 over the sine 34. If we type that in our calculator, we get that ZY is equal to 12.5 approximately. Let's look at a rectangle. The diagonals of rectangle PQRS intersect at T. Given that RPS is 62 and Q to S, this whole thing, is 18, calculate the indicated measures. So if this is 62, this is 62. And we know the angles for a rectangle have to add up to 90. We know this is a right angle. So the other piece of this would be 90 minus 62, which is 28 degrees. If that's 28, this is also 28. We also know that the diagonals are bisected, so this will equal this, will equal this, will equal this. So let's see if that's enough information to figure out these two questions. The measure of QPR, Q to P to R. That's that little slice here that we figured out was already 28 degrees. Then we want S to T. Well, we know ST is the same as TQ, and if the whole thing is 18, this half of it would have to be 9. And our final example. The diagonals of square EFGH intersect at J. Given that JG equals 15, find the indicated measures. Well, we know that if this is 15, this is 15, this is 15, and this is 15. Because squares, all the diagonals bisect each other and the diagonals are congruent. We also know the diagonals cut the angles in half, so if the whole thing's 90, each piece is 45 degrees. So E, J, F. E to J to F. That's where the diagonals intersect. Diagonals intersect at a 90-degree angle in a square. And then F to H. That whole piece. Well, from F to J is 15 and J to H is 15, then the whole thing would be 30. Finally, for your summary, draw a Venn diagram of how parallelograms, rhombi or rhombuses, rectangles, and squares are related.
This is Ashley Gertzig. That's all for today. See you in class.